Yeah, okay. So last time we discussed about variables in Zig, talked about a constant and a variable object in Zig. By variable object, I mean like variable, how to declare variables in Zig and how constants work and the benefit of constants and also the benefit of variables. So in this video, we'll be talking about the primitive types that are offered by Zig, and also how to use such primitive types. What are the pros and cons of some of the primitive types over each other? And so let's just jump right into it. And if you are just joining this video, you notice we have like I pulled up a book chapter. It's a fairly new book. No, I don't think it has been published yet, but you can check it out. I'll add the link to the book in the description. So if we go to our code editor, we'll see that we have outlined out some couple of things, which is the U8, U16, U32, and U64. And the largest one is U128. So what this means is unsigned integer. An unsigned integer is more or less like an integer with from that can contain both negative and positive values, and that means that you have 2 raised to power 8 minus 1, positive 2 raised to power 8 minus 1 to negative 2 raised to power 8 minus 1. That's for U8. The same goes for U16, U32, and U64. By that, it means that you could fit values into a data of that size, like that size bit, and you have to be very careful when you are picking such values. If you only want positive values, then you can sign up for using signed integer, and that means I8 and I16, which I16, I32, I64, and I28. So this particular data type uh, are they are used in such a way that you can only have positive values in them. You can't have negative values. That's going to cause an error. And I think even if you compile it, it won't compile because that can be cut at compile time. So we'll talk about compile time in a bit, but just had to mention that. Another thing is float 16 and float 32, which is with the highest as float 128. On a normal programming language always have like floating point of 64 and nothing more than that, but Zig offers you more than that. You can have floating point of 128 bits. So going back to the editor, how do we use such integers? So here over here we have a variable that is of U8, which can take 78. So the reason why 78 can fit into this is because 2 raised to power 8 minus 1 should contain 78. But if we shift it up to 2 raised to power 76, if we shift it up rather to 276 as a value, we will notice that it's not able to fit in that because we can only have 2 raised to power we can only have 256 as the highest value. So let's test it out to see what I mean by that. I can pull out terminal, and then we'll write Zig cd into variables, and so you can just write Zig run, and so let me just cd into Zig run. So Zig run me. So we see that 2 raised to power 76 causes an error. So and the error is that U8 cannot represent an integer value of sorry 276 rather, because it's an error, and that means that the U8 cannot represent that value. I keep saying 276, which is rather wrong. It should be 276 as a value, and that means that if we have that, we have to either reduce the value to like 2 raised to power 55 to 255 rather, and that will give us that our value should fit perfectly inside that data, inside that variable rather, and you can see that we have it in that variable. So similar case for 7908, which is for U16, and so we're going to have the same error because it can't fit in this. So to make changes to this, we can increase our data to be able to fit to raised to power 32, which is U32, and by U32 it means that we can only have positive value in, sorry, we're using U32, we can have both positive and negative value. Assuming we switch it into I32, we will only be able to put positive values in it, in the variable. So now we have our values out. Yes, so you can fit in that. So the same goes for every other types that are offered by Zig, but there are other extra types that are offered by Zig. Some of them are Boolean for true or false values, and another one is C binary, abstract binary interface type. That like it allows you to be able to interact with C itself, language C. So you can interact with C longs and C character. It's just like interacting with C programs, because C offers you these types, so you can interact with them with those types. So another one is the pointer types, which is I size and U size. And the reason why we have I size and U size is I size is meant for only positive values, while U size is meant for both positive and negative values. So say you don't know the value of a particular variable when you're writing your code. What that means is that you want to like increase the value at runtime, like, which means that when you are running your program, then it means that you need to have like a variable that allows you to increase its size at runtime. So yeah, you have to do that. Zig allows you to use usize, and then you can have a for loop to increase the size of that variable, and to increase the value of that variable rather. So if we run this, you see that we have 45, and because we don't know the size when we were writing the code, that's why we had to use usize. So that's the difference between using like a compile time. At compile time, these values are known. Like this, when you are compiling your programs, these values are known, and that's how you're able to get like 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 errors during compilation, telling you, okay, you've exceeded the value that's allowed for U32 or not. But for U size, that is left for the runtime. So when it's running, when the program starts running, you start this particular piece of code is executed. So going forward, let's take a bit. Let's take a look into arrays. What are arrays in Zig, and what does Zig offer with arrays in Zig? So a quick example will be a constant variable. which is of u8, has a value of 4. So the way you write the syntax for this is you have the size, and then you have two curly braces with the values. So once you have this size and values, the values are just list of values of the same type that can fit in this array. The reason why I mentioned of the same type is that you can't have a decimal point, like can't have mixed values, like that's as opposed to languages like JavaScript. You have to have like the same data type within the array. And the same goes for any other array you're writing, probably the string version too, which you will see in later subsequent videos. So another thing is that there's you can have of other types. You can create arrays of other types, but then say you don't want to have to like count the number of values that you have in your array. There's something that you can use. You can use an underscore, and this underscore is telling the compiler to, you're delegating to the compiler to do the calculation of the value, to calculate the number of values that you have for an array in a particular array. And that means that if you have this syntax over here, if you're going through this guide, you find out that it's for lazy, it's just like a lazy way to like tell the compiler that, okay, just figure out the count, the number of values I have in this array, and just put it right here. So the compiler is able to do that, and this won't cause much of a problem. So then we can go down to indexing. So what is indexing? How does Zig do indexing? So it's zero-based indexing. That's what Zig offers for everyone to like index into arrays. And by indexing, it means like you're locating each of the elements that you have in a particular array. An example is using you can index into the first element in ls over here. So you have 432.1. That should be the result. Let's take a quick look at that. So you see that we have 432.1 as the value. So another is slicing, which is if you come from other programming languages, you'll have seen that you can slice values around. Zig also offers that. So you printing this out, but we'll talk about formatting characters in subsequent videos also. But for now, you can think of this syntax as a way that we get things printed out to our standard output. So over here we have oh sorry, I did not do this the right way. Should have that's for printing. So then we have our values. So we have a slice telling us that this is the values from index of 1 to 3. And if you the syntax for slicing is you have a start index to to the end index, but not including the particular end index. It's just like you got to the second to the last element, but you are not using the last element. Something similar to that. That's just how Zig does index slicing rather. So then we can then check. Let's see how to like have a copy of a slice, which is virtually like it's not a copy per se. It's more like a portion of an array that you just want to get the address of that particular portion. Subsequent video would look more into this by drawing diagrams to understand what's the difference between a slice and an array. So we have something like this, an example like this, and we can update this code. So this is a redeclaration. Okay, let me just use S1. So we start from 0 to array dot length, that is the length of the array, and the an array in Zig has two attributes, which is a pointer and also the length of the array. So by pointer, it means that the starting, the location, the address of the location where the array is starting from, and then the length is used to calculate the number of values after the first address location. And that means that you have like something like you have the address of the first index. It's just like, think of it like you have a an estate and houses are placed next to each other. So you have the first address of the first house, the second address of the second house, and like that. That image description is just exactly the way an array is organized. So you have the index, the array, the address of the first element. Then if you shift to the front, you are going to have the address of the second element, and like that. So the length of that array is also an attribute to this particular variable. So if you do the array.length, you will get the exact length of this array, and then you can use it to index through the array. So if you compile this, you see we have a slice of the values to from the starting index to the last index. And if you recall, I said array.length. So the length of this array is actually 4, but the index, the last index, is going to end at 3. So 0 for this whole line equates to saying something like 0 dot dot, like 0 ranging to 4. So you have 0, 1, 2, 3, and that means you have the whole set of values that you have in this array. Okay, so let's say you want to index from 1 to, not just from 1 to the end of the array. You can just ignore using the last end index. You can skip that, and what you have is you have this. You don't really need this one, so you can have this as S3. And if you do print, I think we have NS, yes. So we have 24, 12, and 6. So that means that we can index from any position to the end of a particular array without having to specify the end index. So another operations that are offered by an array for in Zig is you have let me use debug. You have concatenation. So this is the syntax that allows you to merge two arrays together, and then you have a new array. So what you have here is the combination of the first array and the second array. Another one is multiplication, which is going to multiply. It's going to multiply every single value that you have in an array with the particular value you multiply with the array. So over here we have keyboard. Okay, I'll take this. Okay, So if you test this, we have something like 246. Okay, what did I do there? Oh, try. So we have, oh sorry, it's going to duplicate it twice the value rather. Uh, we are going to, so we are going to have 1 2 3 1 2 3 twice. So another thing to mention now is what is the difference between runtime and compile time. So um, slices are known to have like a range at compile time, since we know the range of the value, and then we know the starting index of that value. So that means that if you provide a start index for a slice, the the starting position, there's a pointer to that particular position, which and then there's an allocated length to that position. So for this particular uh, like the particular length that the compiler can like during compile time can assert, it means that your the slice has the start index and also knows the length of the 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 slice that was provided. By that I mean the the length of the actual slice that you say that you provided to the compiler. Uh, okay, so like I was saying, or rather, like as I was saying that for each slice, you have a an index location to the start, which is a pointer to the start of the slice. And then you have to the length of the slice. Um, Let me draw it out so that it can be a lot much like more clearer than I should be able to put something out like this again. Let's say we have an array which we have 0 1 2 3. So this is an array. So an array is going to give us a pointer, have a pointer like something to locate the first index of this array. So then the same array is going to have an attribute called length. So in Zig, you have let's say this is a variable a, and it's a pointer to an array. That is, it's an array. That means this particular variable has two attributes. It has the location, the pointer to an array, and then it has the length. So this pointer is going to point to the first index of this array, while also the length can be the length. We have the length at compile time, so the length is known. But for a slice, on the other hand, we have, let's say we have a slice B, and we have starting from 1 to, let's say, to 3. What that means is that we're going to have a pointer, and then we also have a length, and this is going to point to this first, and also to the first index, so to the index of 1, and then it's going to have the length of the slice, which is going to stop here, which is 1 and 2. So it's pointing to the same array, but just pointing to a different location in the array, and you can have that copy of that value for slice B. So that's what I mean by having like a slice value. So another thing to talk about is what about if we want to have an array in run at like runtime array? So we could use something called an allocator. We will talk about that in subsequent video. So we have an allocator. We bring out something called an allocator, which is going to allocate memory for us, and then we are going to use that to are going to give it a size. Then we can allocate a like a particular block of memory where we can store values in. For example, in this case, we are going to ask, if we are working on a Windows system, we are going to give this array a size of 10. Otherwise, if you're working on a Mac or Linux, we're going to have, or other platform, OS platform, we're going to have an array of size 12, and then we can allocate. We're going to have a size of 12, but then we can allocate that a memory block of 12 or 10, depending on the platform, and that's going to give us this same compiled, like this compiled array, but at runtime. At runtime, it's more like it can change, that we can dynamically allocate values at runtime, so we can have a slice of that array. So that's the difference between having an array at runtime and having an array at compile time. I will add this code to the repo. When I'll publish a repo, then I'll attach the link to this piece of code so you can play around with it. Okay, so that's the end of this video. I hope to release another one very soon. Thank you, and see you in the next video.